Hello, it's me. It's your teacher, Mr. Hogan, and it's time to practice patterns. Alright, I didn't mean to creep you out a little bit, but I know it's been a little while since we've had a video from Mr. Hogan, and hopefully you haven't forgotten who I am. But it says, which number replaces the question mark? That's our riddle for this week. You can enter into the riddle this time. If you think you know the answer, remember you can earn 500 leader loot. It wants to know what is the question mark on this final domino. There is some sort of pattern going from left to right, and we'll come back at the riddle later on in the video. There are three different types of patterns that you will come across. First is repeating patterns, which are typically easier than others. This is actually a repeating pattern right here, and whenever you have a repeating pattern, it basically means like the shapes or geometric shapes or figures keep repeating over and over again. So whenever you have a repeating pattern, I always say, let's do our ABCs and our 1, 2, 3s, because that's going to help you figure out some future terms. For example, your ABCs, you're identifying the different shapes with letters. So if there's a triangle, all triangles are labeled A, for example. Then you might have all pentagons labeled as B. And then you might have all your squares labeled as C. So in other words, this pattern repeats. The sequence is A, B, C, C, and that keeps repeating over and over again. A, B, C, C, A, B, C, C, A, B, C, C. Now there are a certain number of terms. The terms is the individual shapes in this whole entire pattern. The way you do that is you count them out. So this is term 1, 2, 3, 4, 5, 6, 7, and 8. And these 8 terms make up our pattern. But sometimes you'll have questions that ask you things like, what is the 10th term? And in this case, you might easily be able to say, okay, if it's A, B, C, C repeating, or triangle, pentagon, square, square repeating over and over again, then after square, square, you'll notice that there's a triangle, then a pentagon. So triangle must be 9, and the 10th term must be a pentagon. Seems pretty simple. But then you might get questions that ask you things like the 30th term. Now, nobody has time to draw out all those shapes, and nobody really wants to draw out all those shapes. I guess you could if you really couldn't come up with another strategy. But let's say you're trying to find out the 30th term. Well, one of the first things that I notice about this is that anytime that I have my second square, I'm looking and I'm seeing, okay, it's got a 4 and it has an 8. So that means that I can kind of assume that you would have a square on the 4th term, the 8th term, the 12th term, the 16th term, the 20th term. In other words, it is the multiples of 4 that you'll have the second square. So I know that the multiples of 4 would be 4, 8, 12, 16, 20, 24, 28. I know the 28th term is going to be the second square. And that's actually going to be very helpful in trying to figure out the 30th term, because the 30th term, well, the 29th term is the one right after the second square, which would be a triangle. And the 30th term would have to be a pentagon. You can use that kind of logic to try and figure out various terms, but this is one of the best ways to do it, is to try and identify some sort of pattern and then use little clues to figure out the 30th term in this case. But not all patterns are repeating. Sometimes you have growing, or also known as increasing patterns. This is an increasing pattern with shapes, and one of the best ways to solve these types of questions when it's not repeating is to make it into a table. So tables are really simple. I usually do vertical tables. For example, let's just say this is the figure number, and this is the number of dots. So we have two different things that we're trying to find. Whenever it is figure number 1, we have actually 5 figures here, so 2, 3, 4, and 5. When it is figure number 1, we have 1 dot. When we have figure number 2, there are 3 dots. When we have figure number 3, there are 6 dots. Number 4, let's see, is 10 dots. And it wants to know what is the number of dots in figure number 5. Now, there's different ways that you can go about doing this. One of the first things that you might notice in the chart anyways is that you're not doing anything to go from 1 to 1. But here, to go from 2 to 3, you might be adding 1. To go from 3 to 6, you might be adding 3. To go from 4 to 10, you might be adding 6. In this case, you might not be able to identify a really easy pattern, but there might be a pattern maybe going for the dots. So here you're adding 2. Here you're adding 3. Here you're adding 4. So maybe here you might be adding 5. So in other words, this must be 15 dots. Now you can do this in a variety of different ways. You might even notice on the shapes itself, it keeps adding a new row with an extra dot to the previous term. So in this case, it added 4 dots in figure 4. Now it's going to add 5 more dots in figure 5. So you could also use that kind of logic as well. Here's another type of increasing pattern that might be simple to see. For some of you, maybe not. One of the best things to do, as I said before, is to make a chart to try and see if there's a pattern you can identify that way. You can also look at the actual dots in the shape itself to see if you can find a pattern there, but sometimes you can't. So let's say I have figure 1, 2, 3, 4, and 5. And that's a horrible 2. But in figure number 1, I have 1 dot. Figure number 2, I have 4 dots. Figure number 3, I have 9 dots. So one of the first things I noticed here is that it is it could be a multiplication type of pattern. For example, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. So in this case, this would be 4 times 4 is equal to 16, and 5 times 5 is equal to 25. So in the 5th figure, it doesn't even have you draw it, it just wants to know that there would be 25 dots. Let's look at this one. This is another increasing pattern with shapes, and let's just say we want to make a chart, and we have the shape number here and the number of sides. So for example, shape number 1 has 3 sides, shape number 2 has 4 sides, shape number 3, 5 sides, known as a pentagon. Shape number 4 has 6 sides as a hexagon. 5 would be, in this case, if you're kind of noticing the pattern, the number of sides keeps increasing by 1. So that might mean that the 5th shape would be a heptagon, which luckily, actually, let me pull that up. Heptagon looks like this. So that would be the 7th shape. And then you also have the 6th shape, which it wants to know probably would be an octagon, also known as the stop sign that you see on the way to school every day. But that's another type of pattern that you might see. Now there are increasing and decreasing patterns for numbers. One of the things about numbers is sometimes it's easier to identify patterns that way because, for example, over here this is an increasing pattern and over here is a decreasing pattern. So, and I realize that this is actually an I and an N, not a W. Horrible, Mr. Hogan. Increasing and decreasing. Increasing goes up, and if it's going up and up and up, then you're probably using 2 different operations, probably addition or multiplication. If it's decreasing, going down, 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 hello, like Adele, going way down low, she has really a low voice. This pattern is probably division or subtraction. So in this case, I'm looking at this pattern and I'm noticing it's going up. I notice that it goes up by 6, so it keeps adding 6, add 6, add 6. And so my last term must be 36. Over here, I notice that it's going down, and I'm not really sure. 750 divided by something gives me 600. I have no clue what that would be. But I do know that it's subtracting something. And it seems to be subtracting 150. You might say, well, how in the world did you just figure that out? Well, I literally took 750. I subtracted 600 just to see, and I got 150. And I know that 600 minus 150 gives you 450, and 450 minus 150 gives you 300. So my rule is minus 150, and my last number must be 150, because 300 minus 150 equals 150. Now let's look at this rule. What is the rule for this pattern, and what number comes next? Now sometimes patterns can have 2 different operations in one pattern. So the first thing that I notice is that it seems to be going up, then it goes down, then it goes up, then it goes down. So I must be doing multiplication or addition first, then I'm doing subtraction and division. So here, let's say, it looks like maybe I am adding 3, then subtracting 1. But when I go to add 3 to 5, I don't get 8. It seems like I'm getting a 10. So maybe the pattern at the very start was not add 3. Maybe I'm actually using multiplication. So 3 times 2 gives me 6. Then I subtract 1. Then I can multiply by 2. Then I am subtracting 1. It seems like I might have found the rule, which would be to multiply by 2 and then subtract 1. So if that's the case, if I just subtracted 1, the next thing I would do is multiply by 2, so my final term must be 18. Alright, take a quick break in this video. We're wrapping things up here with one last section anyways. These dominoes, I know it's very confusing at first trying to figure out what that question mark can be. My advice to you is to make some sort of chart. So for example, you might say this is term 1, 2, 3, 4, 5, 6, 7, 8. So you might say the terms over here, and you might say the number of dots over here. Huge clue I just gave you trying to figure out what would be in that 8th term, how many dots total, and then that might be able to help you figure out the question mark. We'll come back to that at the very end of the video. Alright, let's skip over that one. Not really feeling it. What is the rule for this table? What number completes the table? Tables are actually one of the best ways to organize information to identify patterns. And so you'll notice here that in order to go from W to Y, I'm doing some sort of operation. It seems to be increasing by something. So if I was to take W and I multiply it by 9, notice how I would get Y no matter what. So if I took 4 and I plugged it in for W, and then I multiplied by 9, I would get 36, which is why there's a 36 in the Y column. You'll notice that the rule seems to be multiply by 9. So if that's true, then down here, if I was to plug in 9 for W, then multiply by 9, then I would get 81 for Y. So this is equal to 81 for that question mark. Let's look at another one. These are not my favorite, by the way, when you got these horribly designed horizontal charts, and that's just my opinion. But what is the rule for this table? What number completes the table? So again, it wants to know how are you going from J? You're doing something to it, and then you're getting K. In this case, I'm noticing that I'm increasing J to get to K in every scenario, and it might be multiplied by 16, but when I do 3 times 16, I don't get 18. I get 48. So I know it's not multiplication. In this case, I know that 1 plus 15 gives me 16. So it looks like, most likely, J plus 15 equals K. And that the rule is probably add 15. Let me just double check. Does 3 plus 15 give me 18? And it does. 5 plus 15 does give me 20. So I could take whatever J is and add 15 to it, and I'm going to get K. So in this case, K must be equal to 25. And let's look at this rule, or this table. What is the rule for this table? What number completes the table? So this time, I'm taking A, I'm doing something to it, and I'm coming up with B. I'm noticing that I'm going down, so I'm probably subtracting or dividing each time. In this case, I subtract 6, but in this case, I'm subtracting 9. That's probably not the right rule, so maybe if I was to divide by something, divide by 4, I would get 2. Divide by 4, I should get 3. Divide by 4, I do get 4. So it seems like I take A, I divide whatever A is divided by 4, and I'm going to get B. So in this case, 32 divided by 4 is equal to 8. So my missing number must be 8. Last problem of the video, I promise. Here's an in-out chart, which is kind of similar to what we were just doing. In-out charts basically mean that you're plugging in a number and it comes out as a different number. And sometimes the in-out charts are either missing the in column or the out column. But in either scenario, you have to think about what the rule is. So in this case, I'm doing something to my in to get my out number. So in this case, I'm starting with a 3, and I'm increasing it to a 7. So most likely, I'm either adding or multiplying. Now, I don't know anything 3 times something to get me 7, so I'm just going to think about that as adding 4. Now, if I add 4 to 8,
that does get me to 12. So it seems like in order to go from in to out, I would have to add 4. Now that seems to be the rule. But when you have something like x, and you know the rule, you know x plus 4 equals 30. Now, you're not going to do 30 plus 4 in order to figure out x, because remember, whatever you start with, you're adding 4 to that number to get 30. So in reality, what you're doing when you don't have the in, but you have the out, you're actually doing the inverse operation. So you'd be doing 30 minus 4 to get 26. And notice 26 plus 4 does give me 30. 56 plus 4 does give me 60. 60 plus 4, in this case, notice I'm not going to have to do the inverse operation because I'm literally taking my in and adding 4 to it to get my out. I could double check that though by doing, does 64 minus 4 give me my in, which would be 60, and that does check. So that's just something that I wanted to mention about the in-out charts, because sometimes, especially these ones are the trickier ones where they don't have the in but they have the out. Whenever that happens, you have to use the inverse operation or the inverse of the rule. All right, let's wrap this video up by looking at this riddle. Remember, you can enter into the riddle by Friday for your chance to earn some leader loot. I hope you started to work on that chart since the last time we looked at this. I'm actually going to take my charts, copy, paste over into this one, just to make it a little bit easier. You probably have 8 different terms. I'm going to start it for you, but I'm not going to finish this thing, because if I finish it for you, you're all going to have the answer, and you're all going to be like, Mr. Hogan, I know the riddle, I know the riddle. I'm going to say, oh, too bad. So sad, only one of you wins, so... just mean and nasty like that. But term number 1, you got 0 dots. Term number 2, 3 dots. Term number 3, remember this is 1, 2, 3. Term number 3, 2 dots. Whoa, I'm dropping. And term number 4, looks like I've got 5 dots. Whoa, I'm going back up. Seems like I'm going up, then down, then up, then down, then up, then down. Seems like there might be 2 operations. So what could possibly be that question mark? I wonder. Good luck.